Hi, I'm Nicole Bartlett, and I'm NOAA's North Atlantic Regional Coordinator. I focus on working across NOAA mission areas to improve our products and services for regional stakeholders. And that's why I'm so happy to be here today to talk about the CS Coast pilot. We are demonstrating how the translation of satellite data into information can be simplified through meaningful engagement. So, first, a little bit about the Chesapeake Bay. It's the largest estuary in the United States, 64,000 square miles, encompassing one of the most economically significant regions of the country, and is home to more than 18 million people. We already have changes due to a changing climate. Sea level rise is bringing salt water to marshes that aren't used to higher salinity. Species that can't migrate are dying. Grasses and plants that stand a better chance of migrating might run into roads or houses. The range of submerged underwater grasses like eelgrass, which juvenile crabs need as habitat, is shifting. Increased temperatures, changes in precipitation patterns, and rising sea levels can cause hypoxia, which pushes fish away in search of more oxygen and kills shellfish. And more frequent, intense rainfall events can lower salinity in affected areas, encouraging the spread of invasive species that like those conditions. In our case, blue catfish. Cumulative human effects on the ecosystem include overfishing, degraded water quality, and habitat destruction. The Chesapeake Bay program was created in 1983 and brought together government agencies, academic institutions, and NGOs to address nutrient and sediment runoff and track progress. This continued emphasis over decades has made it an ideal location for our CIAS Coast pilot. This fly-in shows you where the Chesapeake Bay is located, if you're not familiar, and in particular, it gives you a close-up on the initial focus in Virginia's Middle Peninsula, a system that includes the York, Piankatank rivers, and Mobjack Bay. This landscape is characterized by scattered farms, forests, and small rural towns. For the last 11 months, we've been engaging with a number of partners in the Middle Peninsula regarding the opportunities Earth observations might reveal as part of their overall monitoring strategy. The first is the Virginia Institute of Marine Sciences Center for Coastal Resources Management, which provides advisory service in wetlands management for Virginia. The Middle Peninsula Planning District Commission, one of 21 planning commissions in Virginia, is charged with promoting orderly and efficient development. They're concerned with navigable waterways and exploring cost-effective options compared to bathymetric surveys. The Chesapeake Bay National Estuarine Research Reserve in Virginia is a steward of 4 unique reserve sites situated along the York River's salinity gradient, which is pictured in the bottom right. And these include monitoring stations for water quality. The reserve leads the York River and Small Coastal Basin Roundtable, a forum for information sharing and collaboration among water quality and conservation-minded stakeholders. Their State of the York report is ready for an update. Last published in 2000, it includes issues like land use change, river flows, shoreline hardening, water quality, and underwater grasses. And finally, the Pamunkey Indian tribe has occupied and stewarded this land for more than 10,000 years. The Pamunkey help assess Atlantic sturgeon spawning populations and expand the ecological knowledge and stewardship of the Pamunkey and Mattaponi rivers. What's been exciting about this process is really connecting Earth observation experts to these local experts. The perception that free satellite imagery is too coarse for these types of applications is definitely changing. Our partners know there are opportunities here, and they simply don't have the capacity to measure everything that needs to be measured. They're interested in any and all products that give them information about this system, especially information that doesn't cost anything. The animation you see on the right is some early stage work on flooding extent using synthetic aperture radar. And on the bottom, an example of the shoreline mapping product that's going to be generated from Geoscience Australia, which Stephen is going to cover a little bit later. We are assembling validation data from these partners and uploading it along with these satellite products to a web-based hub that will allow them to compare their in situ and our satellite products. One of the major benefits of co-developing these products with partners is that we are ensuring we are creating something they can use. Through sustained engagement, We're revealing what's possible through satellites and iterating a product that will be valuable to them. This in turn frees up resources they can strategically deploy for on the ground measurements and local analysis and things satellites can't measure. I'll be available during the question and answer session for any follow up. Thank you, and I hope you enjoy the rest of your meeting.